NOTACON.
No, that's if I drop my pants. I get $5 more if I drop my pants and work it into the presentation. But we'll see how well this goes. So, this entire thing has been fraught with horrible error because I tried to drive 9 hours with a 46 and a janky-ass 12-year-old hard drive. So, the actual computer to demonstrate, like, hey, do this and you get a picture is dead, unfortunately. But you can still look at the amazingly mammoth pile of crap that the device actually is. But don't leave yet, because I have slides, and you're going to sit through them. So I guess I'm Tanner, or Cause, whatever you want to do. I'm speaking on an improvised digital strip/slit/streak camera. So basically, the idea is... Oh, do I have an idea slide? Yes, I do. The basic principle of a strip camera or a streak camera, or there's like 4 different names depending on how you're using it, is that in the film plane of a camera, you guys all went to the beginning and intermediate photography talks, right? So you're all up to, okay. So in the film plane of a camera, you have a little slit like that. So rather than having an entire area of negative exposed at one time, you have one little, I fucking hate it when people don't turn their cell phones off. Instead of getting the entire image at once, you just have basically a line. And so what you do is you move film across that line, so perpendicular to the slit. So as a result of this, you get an image over time, which is different in a different way than if you take a long exposure with a camera and you get an image over time because things are blurred. Because at any given point, the film is only being exposed for a short amount of time, but the entire image can span a longer amount of time. So this is vaguely interesting for reasons I'll get to. Find something useful to do with it. So one, and these are my incredibly crappy, okay, basically it's this incredibly old black and white scanner that only interfaces with an ISA card, which is why I had to drag a 486 here with the drive failure and whatnot. But this is what you get when you take a subject. You have the camera stationary, so it's only exposing a little bit of it at a time, and you spin the subject in front of it. You get a rollout, or peripheral photography. This is interesting to archaeologists largely, or art historians, because if you have, say, a vase with Greek painting on it, it's really hard to photograph because from any given stationary point, you're going to have different perspective at different points on the vase. Whereas if you set it in front of the camera, perfectly centered, and you spin it, and you get this nice rollout, you have the same perspective across all points on it, and that's interesting to some people. The other thing that you can do with it is, wow, that's really dark, is you can rotate the camera. So you can get a 360-degree panoramic just by taking it, and because you're running it across this slit constantly, and the exposure is correct within the slit, you get basically a panoramic photograph that can go 360 degrees. That's pretty much that. What people get into more are things with moving subjects. So you have the camera stationary. So for example, in the 60s, a couple of Time Life photographers got film slit cameras and took photographs of Olympic athletes. So as something's moving past the camera, depending on how its position and orientation changes, it's reflected in the image. There's another guy now who is doing really trendy skateboarding photographs by using a slit camera. Because let's say somebody is jumping through where the image is being taken, and they're flipping their skateboard. And then in the actual image, because of the way it moves, you get this nice like corkscrew. Because basically what you're getting an image of is across time of what they're doing. I am moving very, very fast. Other uses, photo finishes, most racetracks. I'm being required to drink. I'm sorry, hold on. It's Coke. For example, at racetracks, because you can set up this camera that is taking a single line in space and making an entire image with it, you can set it up at the finish line of a racetrack, and then you have very nice proof of, oh, that horse's nose crossed that line in space first because you looked at the image. Aerial mapping is another one. Basically, because like for the same reason that if you take an image, let's say from an airplane with a wide-angle lens, you get different perspective at different points in the image. So you're pointing straight down. Buildings on this side, you're going to see the near side. Building is on that side, you're going to see the near side. But if you set it up pointing straight down, as the plane goes over, you're going to get the same perspective on everything straight down. That's all I've got. Blah, blah, blah. I'm actually in competition with Irish for the worst slides of the conference right now, but I really... Did he already walk out? I guess I did sleep. Oh, that's... I feel better about sleeping through his talk. So, basically... this is all talking about it in terms of film, where you actually have to rig a mechanism to wind film past the slit in the camera. Well, there's a really common piece of technology that uses just a line and creates an image by taking progressive samples along that line, and that's most computer scanners. You have something like a mirror under a light that moves across your flatbed that puts the image back into a nice little lens that focuses it on a linear CCD. Now, those are bad because generally the scanner does not work continuously. It goes an inch down the image, fills up its cache, it writes it out. It goes an inch down the image, writes its fills its cache, writes it out to the computer, and it pauses. And that's no fun because it's not continuous. But, and unfortunately they don't make modern versions of this, there's the portable document scanner. I'm sure you've all seen them. Little handheld thing that you put on something and you roll it down and you're supposed to scan text with it. Well, what that does is, just like a mouse, it has a little wheel with gaps in it, and then it counts how many times it hits a gap, so you can actually control the rate at which it's sampling, which is useful for the previous uses. Useful for uses, right. Simply because if you're, say, taking a panoramic, if you run out of space before you get around 360 degrees, that's bad. If you have a ton of space left over, you don't have a whole lot of vertical lines involved, that's bad. So what you can do, and this is the bit where I really wish this was actually working, what you can do is basically take, and this is my amazingly awesome diagram here. Can I hear some oohs and ahs? Nice. What you can actually do is, there's just a gear train here. You hook up a, what? you basically just hook a motor up to it with oh great, I don't even have the fucking variable resistor in the photograph. You basically hook a pot up to it so that you can control the speed at which the motor's turning, and then you can control the speed at which the scanner is sampling, and then you can control exactly how many vertical lines it's taking over the course of time, which is just like controlling the rate at which film is moving across, except since this thing has this nice dial here, on the actual scanner, one side of this is black and one is white. So you're just setting your exposure for the scanner by turning this dial, just trial and error. Don't ask me what the ISO of it is, I never really properly figured it out. And then what you do is you take the linear CCD, which, oh, check that out, I've got a picture of. That's a linear CCD. You're all impressed, right? And you take it and you slap it in the film plane of a camera, and what I've always used is either a Mamiya like twin lens. The nice thing about twin lenses is if the shutter's open, you can still look through it, unlike like 35mm SLRs. Or this is actually an old Kodak Brownie, which really impressed a lot of photography people because they're like, oh, you're mixing technology. Oh, it's like early 20th century and late 20th century. The theory! But it was more that it was free, like the scanner. What? I know, there's very little Girl Scout jokes involved. Although now I feel so bad for not putting a slide in here with the brownie joke. What a total failure this talk is. I'd really love to demonstrate this because it's really fun to play with. Yes. You know, the absolute saddest part of this is that camera actually going? Yes. The saddest part about this is that at some point, someone is going to pay money for the video of this. Yeah. Right. No, I mean, like I didn't want to say that it's funny that you guys all paid to get into this conference and I didn't. Which is funny, but the fact that my total and utter breakdown and failure is being recorded for posterity is just really amusing to me. Whichever. So at any rate, you can make one of these by modifying a film camera and sticking a motor on the film rewind and then doing all of these things. Or you can take a $3 scanner and slap it back in the back of a camera and you can play with it. And it's actually really interesting in that it's terribly easy. And this is way more complicated than it needed to be because the cable was a little short for my purposes. But you don't actually need to modify it any. You can actually just crack the case, and usually there's a short cable that's long enough for you to fit it in the back of a camera, and then you can play with it. It's fun. You can do things with it. I've totally lost it. So, dude, is there questions why I'm up here? I'm sorry, no, the actual pictures are these sort of illustrative pictures here. These actually came out of the camera. I used the cheapest one. Actually, if you guys know Enclaved actually bought this scanner off of eBay for me because I don't use PayPal or anything. So like you can thank him for this. But this is I mean, like this is like literally like the first model of Logitech's portable document scanner. So you get something like 16 shades of gray, which is why these images look just so detailed and sharp. No, that's not right. But more or less, there's actually a guy named Andrew David Hazy, who is at the Rochester Institute of Technology teaching in the photography, the technical photography program, who's done the same thing using basically what he did was he took a 4x6 color photo scanner, sort of like the most consumer grade thing possible, simply because it was designed to read the entire thing in one go. So unlike a large flatbed, which will read chunks and then deal with actually storing the data, it just reads the whole thing in one go and does it. And his images are a hell of a lot more impressive. But since they made me sign the copyright form, I couldn't include other people's images because there's, all right, you know, it's bad when I'm being pressured to drop my pants in the middle of a talk. Take it off! But I mean, he's actually, no. But more or less, so you can get a lot higher res and color, and actually if you get some of the later models of the color portable document scanners, I mean, it works the exact same way, but you get a lot higher resolution and in color. This is actually full resolution, and you can still see the pixels, which is really, of course, when I say that, the screensaver kicks in. I should have thought of that before I plugged this in. But I mean, basically you get that. There's a guy in Japan, actually, who takes pictures of entire trains by setting up a slit camera in one place and then waiting for a train to go by. Then he starts the exposure, and since he has already figured out the speed that the trains go along a certain set of tracks, he knows exactly how many samples he needs, and gets these, I mean, like, they're really mammoth, like something like 48:1 perspective images, where it's the entire like bullet train or things like that. But he's a nutty Japanese guy, and yeah. A flatbed photo scanner. That might actually be the same thing that you use. I was actually looking for one, not for this, but you can make like a 122 megapixel studio camera by getting a 4x5, because I've got a 4x5 view camera, and if you slap a flatbed on the back and use CKMY filters on the front, you get 4 different exposures. and then you add them all together and you get this massive thing. So I've been looking for something like that, but so this is entirely broken down into things that can be handled at the party later, which is in 522. Room 522 is the bucket party, so you should all come. Where's the money for that one? Oh, then don't go to 522 at around 9 p.m. to drink screwdrivers out of a bucket. Whatever you... No, there's no liquor at all. Just buckets. Oh, wenches? I don't know about the wenches. What's the time? 7:20? Why, I've taken up my 20 minutes. And now I'm going to turn it over to Gabe here, who is going to speak about platinum printing off of digital files. Oh, well, I'm suddenly less impressed, but no, I'm joking.
No metal involved. Sorry. There you go.
They want you to speak into the microphone so that they can sell it to people.
I want my every move recorded.
I'll just put it there. It's easier for me.
But yeah, it's not hard.
that people take $15 if you manage to work with $15.
Oh.
Or $10 if you just drop it.
Oh. Okay. I'm Gabe Schaffer. These are my big prints you might see around here. They look kind of shiny and metallic because that's what I'm talking about here. There was also a fourth big print of a Dairy Queen, which disappeared sometime in the past 24 hours. If you see somebody walking around with a big metallic picture of a Dairy Queen, I'm looking for that. So anyway, a lot of people see these pictures and say, wow, how did you make that? And, they don't realize that there are many ways to make prints from digital files. And there's two. Let's use the microphone. Does this help? Can you hear me now? Okay. All right. So there's two basic ways of creating a print from a digital file. One is to just take a white piece of paper and add some sort of dye or pigment, like an inkjet printer, which I'm sure you're all familiar with. The artistic term for that is giclée, which is French for spray. Yeah. And then you've got your typical laser printers, which use a toner, different colored toners. There's dye sublimation, which uses a fancy technical term called sublimation to transfer dyes into the paper. And then there's a solid ink or wax transfer, which just takes little crayons or ribbons of dye and heats them up so they melt onto the paper. And then the other kind is chromogenic, which is Latin for creating color. And those start out with some sort of white or other colored paper, and then something is applied to them and color is created. And the three terms for that are pictrography, yes, there is a second R in there, thermo-autochrome, and a different kind of laser printer, which can also be LED, CRT, LCD, MLB, as you can see. All right, so you might think, why inkjet? Why not inkjet? Well, inkjets are cheap, they're readily available, they can print on pretty much anything from birthday cakes or boxes on an assembly line, and you can use lots of different colors. You can have an 8-color printer. But the problem is ink is expensive, typically more expensive than the finest champagne. That's by the ounce, not by the glass. And your typical cheap printer that you'd have at home yields not so good output, and even the fast ones are slow because it's got to, make each one of those billions and millions of dots individually. And you see I have a picture here of a very, very large printer. That's called a Durst Row 160. What, the Durst? Well, pretty much everything degrades over time. If you're familiar with the iron death of the universe. Now, anybody who wants to hurt her can find her in room 522 at 9 o'clock. Okay, so printers can be cheap. They can be expensive. $250,000 for this guy right here, if you really want one of those. I don't know if they sell those big ones on eBay. But anyway, you know, a print from one of those might cost $1 and take many minutes to print. If you've ever tried to print, you know, a whole bunch of them at once, you got to wait a while. All right, laser printers, like you typically see, they have toner. They one great advantage of them is it's easy to duplex. You can print both sides. That's one of the pretty much their only advantages for printing photos, because they're not photo quality printers. The toners don't, you know, they're designed for making pretty graphs and stuff, not photos. And your laser printer might cost $500,000 to $10,000. You're still paying about $1 for an 8x10, but they're not that fast. Okay, now dye sublimation printers. These are actually very common for printing out photos. You might see them at your local grocery store or drugstore. And one cool thing is they can laminate, print gold leaf, not just regular dyes. And here is a picture of one that we have at the lab where I work. It's called a Shinko. And this Kanematsu company makes Shinko, and they make dye sublimation ribbon engines for many printers. But a good dye sub costs anywhere between $1,000 and $15,000. Costs a little bit more than 8x10, $1.25. And the one I showed you takes about 30 seconds to make an 8x10. And then you got wax transfer, which is not really a good way to print photos. Now, pictography. This is interesting. This is the best part of digital printing. It actually prints a real photo. I guess what you would call a real photo. It's silver-based, like other real photos that you'd get at your local lab. And problem is, it's kind of expensive and not that fast. In case you're wondering how it works, Fujifilm invented this, I don't know, 10 or 15 years ago, and it exposes a photosensitive paper to light, but instead of red, green, and blue, it uses like infrared and red light, 750, 640, and maybe 870 nanometers, if you're interested in that sort of thing. And then it uses heat to develop the picture, and then presses it against a white receiver paper, uses water, and you got yourself a print. Problem is, the print cost $2 and took about 1.5 minutes to come out. But at only $4,000 to $8,000, it's a lot cheaper than, you know, an $80,000 mini lab. And more recently, Fuji came out with this thing called Thermo Autochrome, which is sort of a whole scale in terms of photo printers. It has no consumables whatsoever. No water, no ink, no dyes, no ribbons, no toners. All you do is you put the paper in one end and prints come out the other end. The problem is they don't make general purpose ones. They pretty much only print on 6-inch paper, and you can't just go out and buy yourself one in the US. And the way that works is it's got 3 layers on the paper. You've got a red layer, magenta layer, and a cyan layer. So to make a print, it passes the print under a heating element, just like a regular thermal printer, and it uses low heat to a yellow, and then it passes the paper under a UV light, which essentially fixes the yellow so that additional heat won't change it. Then it uses more heat to create the magenta layer, passes it under another ultraviolet light of a slightly different frequency to fix that, and then it uses even higher heat to create the cyan layer. And poof, you got yourself a complete color with absolutely no waste. good for the environment, good for Fuji. I don't know why they don't make more sophisticated printers. But the printers aren't necessarily cheap. They run from $600 to $6,000. It only costs about 75 cents for an 8x10, which you'll notice is the cheapest here. But they don't make 8x10 printers, so we're out of luck. Now, the most important part of this thing is really why I'm here, are regular light-based printers. They use what they call an RA4 process, which is the way color prints have been made in labs for probably about 20 years. All you do is you expose paper to light, run the processor, and poof, you got a photo. The problem is exposing that paper to light is tricky because you got to make sure each of your pixels is exposed as just the right color. So, the way these printers work is you have a big roll of paper, you put it in the machine, and you tell the machine, here's the image to print. You give it a TIFF, a JPEG. Some use PSDs or whatnot. So, so the way the light-sensitive paper works is it, again, has 3 layers. One for cyan, one for magenta, one for yellow, which are exposed to red, green, and blue lights. The lights can be created by any number of methods. You could have a thin CRT, which you just press up against the paper, like one line, a red, a green, and a blue line. There are also fiber optic methods, which basically just take a white light bulb, shine it through a whole row of fiber optics, and basically turn each fiber on or off, as the case may be, and as the paper passes under it, and to expose it. Another method, which is starting to come into common use, uses a method just like these projectors here. You shine a light through an LCD or digital light processor, those little micromirror things, to project an image onto the paper. The problem is, if you look closely at these things, you see a little screen door, sort of, because there's a little gap between the pixels. And most professionals don't like that on their pictures. So the best systems use either lasers or LEDs, regular light-emitting diodes, to expose the paper to light. And then the photons knock electrons in the silver to a different energy level and creates what we call a latent image. It's an image, but you can't see it. I guess it's late. So the next part of the process is you take that exposed paper and you develop it. In some machines, the developer is attached right there, and in other cases, you got to take the roll out in the dark, put it into the developer. So the way the developer works is there's a chemical which reduces the exposed silver halides into pure silver, and then the oxidized developer combines with dye couplers to produce colors. You can read it all right here. I wish I had some more cool pictures to show you, but no thanks. I don't drink. So then you end up with nobody told me to prepare for the for drinking. Don't worry, I will be dropping my pants at the end of the okay. So then yeah, feel free to feel free to make a further mockery of this auspicious presentation. Okay, so take your print, you run it through the developer, you then bleach out the rest of the silver, you wash it off, and bam, 4 minutes later you've got a perfectly beautiful color photograph. Now these colors are unfortunately a little bit expensive. They $50,000, they go up to about $350,000 for the bigger ones, and if your printer doesn't have a processor built in, you got to pay $5,000, you know, for like a used one, or $50,000 for a nice big new one. The advantage of these expensive printers, though, is the whole cost is only about 15 cents for an 8x10. which is a lot cheaper than the other ones. You'll notice the other ones went down to maybe 75 cents. These are 15 cents. So if you're going to be doing a lot of printing, this is what you want. And another advantage is they're fast. You can, well, I won't skip ahead. But anyway, you can get 600 8x10s an hour from the one I'll be showing you later, which is a lot more than you're going to get from an inkjet. So here's a little description of how the paper works. You've got 3 different dye layers sitting on top of just a regular white piece of paper, and different colors exposed, different layers, and you develop it, you get your nice pretty colors. This beautiful metallic paper works almost exactly the same way, but the white base includes voids, as Kodak calls them, and that causes a specular reflection instead of diffusion, and you end up with a metallic looking print, which apparently lots of people think is very cool because they invited me to talk about it. Unfortunately, this beautiful metallic paper costs 2 or 3 times as much as the regular paper, and it's very hard to find a lab that prints it. If you're interested, I have a ton of business cards though. So, a lot of people wonder how I made my photos. That includes these big ones here and the ones showing up along a cloak out in the hallway there. So the big ones, these guys, were printed on a machine called a ZBE Chromera 30 and processed on a machine called a Creonite KM3. The small ones, the clothesline out there, those were made on a Noritsu 31 Pro, and it's got a built-in processor. Yeah, well, I just thought you'd be interested in the technical terms. Okay, so these big ones that were made on a ZBE Chromera 30, you've got a picture on the outside on the left, and on the right side you can see the innards. You've got a spool of paper here, which unwinds, goes over this drum, and here's the printhead. This printhead moves back and forth, exposing the paper to light, and it gets taken up here. Very simple. Yes, you might be wondering, gee, if this paper is photosensitive and he's taking pictures with a big flash, does that not ruin the whole roll of paper? Well, we in the industry have something we call a dummy or blown roll, which is paper which we can no longer use, and thus feel free to experiment with when training people how to load the printer or taking pictures for presentations such as this. And so anyway, this is a 30-inch wide roll. Goes up to 165 feet long, which means I could make a print up to 165 feet long, which are pretty rare unless you've got a slit camera. Yeah, that works. So this very machine only has 4 motors, and like I said, it's very simple, and uses Windows to basically send controls to the motor controller and the LED controller. And so anyway, after you take the paper out of the take-up side here, which ordinarily you would do in absolute darkness, you insert it into this machine called a paper processor. Here we've got a side view, we've got a front view, in case anybody is wondering what it looks like. Now, here is what the inside of it looks like. The paper comes in here, goes down into this tank for the developer, goes down into this tank here for the bleach, and then it goes down in here to get washed. After it's washed, it comes across here. This gap is actually not that big, but it allows me to stand here without blocking that. So anyway, then the paper comes down here, gets blown across a big dryer, and comes out the other end, and it's dry, and you get a nice big fat roll of prints, which you then have to cut up. Cutting it up is not covered in this presentation. The cutting? It depends on whether or not you have a manual cutter. So, yeah. Typically, employ a nice, cheap, illegal alien to do your cutting for you. His name is Manuel. The other option is doing it yourself or purchasing a machine that costs about $15,000 for one that just cuts it up into little strips, which you cut further, or an XY cutter, which costs about $30,000 and will take your huge-ass roll of paper and convert it into little 8x10 prints for you. Yeah, this cutter uses small blades, not huge lasers. So, no. All the lasers in the printer. So the printer, which I use to make those little ones out there, is made by Noritsu, and they call it a 31 Pro. It's called Pro because it doesn't come with the $80,000 film scanner. So you can make prints is by having digital files already created, presumably means you're a professional. Everybody who runs a regular lab, has film that they need to scan, so they're not professionals. Yeah, film is not professional, yes. Yeah, film has now been relegated to artists and people who are too cheap to get digital. Yes. You either have to scan your own film, which, if you're professional, no doubt you have a much higher quality film scanner, or you use a digital SLR, which most of the customers of the lab where I work use. Yes, your question? No, professionals, photographers use film, but clearly their career is of limited duration. So anyway, seriously though, folks, this particular machine can take 2 magazines of paper up to 12 inches wide and up to 600 feet long. It can make up to 12 by 18 prints, and it moves the paper past the lasers, which did not come off of frickin' sharks. Anyway, it can expose 150 inches a minute, which is extremely fast, considering how fast paper moves through, say, an inkjet printer. But this is a very complex mechanism with 13 motors, and it has a stupid little Windows UI, which runs on a computer, and that particular computer sends the bits off of its hard drive to another computer over some fiber optics. Yeah? What's your question? Wait. What are you asking? Yeah, well, actually, failure is not an option. It's been my experience that the simpler machine is actually more prone to failure because the more complicated one, I think, has been around more to have its bugs worked out. The bigger machines obviously do not sell in such large quantities, and only recently was the 300th of this variety installed. Whereas Noritsu has been making mini machines for decades. So, yeah, it's so instead of being a pretty much handmade device, it's designed in Japan with high quality processes, no doubt. And as it turns out, this thing's got like sensors all over the place, and it detects things that like paper jams and stuff. So it's pretty reliable. Yes. A high quality film scanner is definitely a bonus if you're going to be scanning film. If the problem with cheaper film scanners, which, I mean, even the one that comes built into this machine, if you're willing to pay an extra 80 grand, is the problem is that it doesn't have the dynamic range. And so you take your film and you scan it, and you lose either your shadow detail or your highlight detail or both. And most don't notice because either they don't have that kind of detail or they don't realize it's missing. Beauty of digital cameras, if you are afraid of losing that kind of detail, you can just use raw format, and we got no problem with that. All right. Oh, this by the way is the what the front end user interface on the innards looks like recently. All right, what's your question? No. No UV or infrared light is actually recorded by cameras, because I mean, unless you have a very special camera, you could see. As it turns out, optics with typical cameras are designed to operate in the human visible light range, and cameras which are designed for IR, which is, as a matter of fact, infrared is very easy to pick up on a digital sensor, and so like professional cameras where color quality is very important go to great lengths to put in expensive infrared filters. Yeah. Well, there's the human perception system is pretty much impossible to duplicate properly with just a simple linear response image sensor. So people just do their best and leave the rest up to Photoshop. Anyway, getting back to the topic, this is the screen, and one of the niftier features is it shows you each print as it goes along through the developer. So here are prints coming along down into the developer, and then here this one it's about to go into the bleach, and here the stabilizer section where things clog up because there's actually like 4 tanks, not just one, and then up here into the dryer where it'll pop out here and then go on a little conveyor belt into this sorter. You can see also that it's got about 10 gigs of space where it stores the uncompressed images that it's about to print, and stuff like, for example, up at the top where it says printing except number 349. This was clearly written by somebody in Japan and translated, because I have no idea what that means either. Okay, so here is a photograph of the machine in the lab. Over on the left here, you see what is the little operator station. It's got a little PC that you can see in there. Here, let me point it out. PC. Here is the little place where you put in calibration sheets so it can calibrate itself. And here's a little monitor with the interface. That part is okay. It looks like I have 10 minutes here. So the middle part, that's where the actual lasers are on the paper and all the nifty stuff with its 13 motors, and it's 3 freaking lasers. And over here is the processor, and just like we saw in that paper before, you got your little development tank, your bleach tank, your various stabilizer tanks. Here's the dryer section. Prints pop out on here, and you can see these at many places that develop photos. Walmart might have machines like this. Anyway, well, as it turns out, that printer prints on metallic paper or glossy paper, or any other paper that you can get for it. The metallic aspect is simply the little voids in the base of the paper. So here's some innards of the printer. You got some paper magazines here, which get loaded in here. This is where the frickin' lasers are. Paper gets drawn out of the magazine, gets cut a sheet, goes up here, over past here where it's exposed, and these are the tanks of chemistry, which we don't use. So anyway, to wrap things up, here's I thought I'd present some real-world examples of where you'd actually see these different kinds of printers. Inkjets print pretty much everything from cake or actual printers, which print directly onto cakes. They cost about $10,000 or $11,000. You can get them from pieceofcake.biz, I believe. Or you could get kits at home for your own printer, which use sort of edible dyes, and they print on little sheets of sugar. I have yeah. Well, actually, they look pretty good. I recommend eating the metallic paper. Metallic frosting. That's a good idea. I don't know. I don't know if you can print a metallic birthday cake properly. Actually, wedding cakes tend to have that sort of crazy-ass stuff. And somebody somewhere could probably do it, but that's a little bit beyond the scope of my knowledge, just slightly. But I do highly recommend, like, if you're going to be printing a lot of cakes, or possibly other foods, you definitely want the kind of printer that can print directly on it, because otherwise you have to print on essentially a sheet of sugar. And yeah, it has a straight paper and or cake. Is it? Turns out there's this. I'm sorry? So anyway, you get a much more professional look from the actual dedicated cake printers than from just doing a standard inkjet conversion. Yes, you put. Okay, a cake printer costs about $11 for the investment, but once you've invested in it, the consumables are very cheap because it's just essentially the dye, the food coloring based inks. If you're going to do a food printing conversion to a regular printer, you have to keep paying for these expensive, rice paper or sugar paper substrates that you don't want to have to do. So, I'm sorry? Yes. Actually, paper jams are a common problem. Root somebody with a cake printer. That's, I'd rather not explore that option. Probably not, no. But if you are interested in doing a cake printing conversion, I recommend Canon printers because their ink cartridges don't have any sort of crazy electronics that have to be reverse engineered in order to get the printer to work. You just fill up a tank and with your cyan food coloring and you drop it in and it works. I do not recommend eating cakes printed on, which has been used before conversion. Since you ask, the way the dedicated cake printer works is that it has essentially a conveyor which moves the cake or any other edible device, which any substrate, which moves it under the printhead, and the printhead moves back and forth and advances the paper. I'm sorry, what was your question? Yeah, well, that's slit printing is basically how lots of these things work. You just move the paper past a slit. In the case of a dedicated cake printer, I do not know the maximum length. In the case of the conversion kit, you are limited by the size of the paper substrates which are available. And yes, they do make circle cut ones for round cakes. Are there any other questions? Which may or may not involve cakes. It seems little miss. Okay, so you want to know about transparencies. You can. It's not too easy to get, for example, in inkjet ink to stick to a transparency. So odds are you don't want to print transparencies on your inkjet. However, laser printers are good at it because the laser toner just gets fused to it. I'm sorry, what? In a what printer? The next their old 400 DPI black laser printer. Well, it probably just wasn't using the right kind of transparency material. You'd want one that was designed for laser use. Back in 1990, they weren't that common. 91, I'm sorry, but they were 400 DPI and used perfect. It's a good printer. But nowadays, yeah, laser printers are used for printing transparencies. You can print transparencies with the big RA4 printers. Not this. This would have to be specially modified to support it. But this thing can print on transparencies. It just takes longer to develop. And yes, it's absolutely photo quality. The other option is Pictro. This thing right here can also print on transparencies. Yeah, well, no, that's what I'm saying. This guy, you can buy transparency paper for it, which works just like the regular paper, only it doesn't have the same white backing, and it runs through the regular chemical processes. It takes longer to develop, but the only big problem with it is dirt. You have to make sure your processor is much cleaner than it otherwise would be. Are there any other? Yes? Okay, that's an interesting question. He's wondering about how do you make sure that the color is the same each time? Well, these printers have self-calibration mechanisms. I actually had a calibration print in my car. I forgot to bring in. But the way it works is it makes out a standard print, scans it in, and makes adjustments. It's a closed feedback loop. And works very well. And then you have the problem of how do you make sure that both of your printers print exactly the same color. And for that, you use an output profiling system. And what's standard for... Oh, you mean like CIE Lab or sRGB? Or the French? Yeah, that's CIE Lab color. I don't necessarily know how they model the colors inside the printer, but it to some degree it almost doesn't matter. It just knows that the paper is capable of creating, a certain darkness of black and it starts at a certain whiteness of white, and then you've got a whole bunch of grays in between, which are translated to, translated from the RGB that you give it based on an input profile. So you can just say, okay, well, this has got the input profile of sRGB or Adobe RGB or whatever, and then it translates it into whatever its internal color scheme is. No, it doesn't matter as long as they're calibrated to the same. I mean, all you do is say, my input profile is whatever, and it'll print to that. Now, essentially, it sounds like you're asking what's the default color profile, and that's probably oh, how does the printer know that we see the color the right way? That's just basically a question of profiling. I mean, there are color emitters which measure, the exact. Oh, okay. Well, in terms of ink, these printers don't use ink. They expose paper to light, and well, part of the calibration process is aligning the heads, essentially. And yeah, well, actually, it guarantees the color and the head alignment. I could explain the way it works, but probably the rest of the room isn't interested in that, and we have to. It's 8:01, so this is officially over. Yeah, I'm sorry. Anybody have any questions now? 225. I was reading my hand upside down. Does anybody else have any questions about the bucket party? Okay. Well, I guess we'll have tonight at 9 o'clock then.